I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll talk about radian measurements and discuss many topics, including how do we sketch angles in radians, how do we relate degrees and radians, what are special triangles, and what is cast rule, relating reciprocal ratios, cofunction identity, and related acute angles concept. This will lay foundation for radian measurements. Our approach, engaging minds, help us to perform much better. We can now connect to context, visualize strategy, apply learnings, and bridge the gaps. Engaging minds help in creative thinking and problem solving. Gain the confidence. Get ready for future. We develop both mathematical and social skills. I can be part of your success story. Build strong foundation and ensure bright future. That is the gift of education. You can always contact me on the email address given. Join my classes. Let us now enjoy the class with Arya. Hi Arya, how are you doing?
I'm good, Anil sir. How are you?
Very good, very good. So today, what do you want to learn?
The cast rule using like radians
Okay.
and graphing trigonometric functions like sine and cos. I
Okay.
think in grade 12, do we only do sine and cos for grade 12 advanced functions?
Here we do even the reciprocals, right? So cotangent,
Yeah.
secant, cosecant also we do. But we can definitely begin with graphing sine, cosine, and tangent today. We can do that. And we'll look into the radian measurements, which is a big thing for you. Correct? Now,
Definitely.
if you could just share with me, we'll quickly go through your questions. And on the side, I'll explain you the concepts behind solving those questions, right? So that is how we will continue our class today.
Sounds good.
Great. So I think here you're beginning with showing me the special triangles to begin with.
Yes.
Right. So do you know special triangles?
I know them, but I don't remember them.
Okay. So nothing much to remember. Let me just teach you on the side what these triangles are so that you don't really have to remember. You have to form a picture in your mind. So let me just give you the first triangle, which I can see as 90, 45, 90. So when I say 90 and 45, they are in degrees. We will look into radian measurements, right?
So pi equals 180
So
degrees.
let me just write down here as you are saying pi is 180 degrees. So I'm writing 180 degrees as pi. 360 degrees will definitely be 2 pi. And if I want pi by 2, okay, so let me just get back to pi by 2. It'll be 90 degrees, correct? And pi by 4 will be half of 90 degrees, which is 45 degrees, correct?
Okay.
So this part is clear. If I divide pi by 3, then we have to divide 180 by 3. You get 60 degrees, correct?
Okay.
And half of this is pi by 6, which is 30 degrees. Does it make sense to you?
Okay, so if pi equals 180, then whatever your denominator is, you're just dividing pi by that, so that
Yeah.
equals to your that makes so much more
So
sense.
easy. Do you see that? So
Yeah, you
let
don't have
me
to convert it. So I
It
need to say
is, it is,
pi.
it is, it is. Do not think about it. Just do say 180 degrees is pi, correct? If I divide 180 by 2, I get pi by 2, and definitely that is 90 degrees, correct? If I divide 180 by 4, it is pi by 4, which is half of 90, which is 45 degrees. If I divide 180 degrees by 3, then I have to divide pi by 3, of course, and 180 divided by 3 is 60 degrees. And if I do division by 6, in that case, I get pi by 6, which is 30 degrees. Does it make sense to you?
Yeah, that makes a
You
lot
get
more
it?
sense.
How easy it is?
Yeah,
Simple as that.
you just need to divide it. That's it.
Yeah. So basically, if you look at it, now let's look at pi. Radian is very, very easy. Uh, You know something, you have a protractor, and this protractor is always in degrees, correct?
Yeah.
Have you ever seen a protractor in radian measurements?
No, sir, I haven't.
Because it has no market, nobody's going to buy it. See, radian measurements you can do without protractor. It is
Okay.
common sense. Look here, 0 and 180 degrees you had been doing, right? Now we are
Yeah.
saying 180 is pi. Perfect. If I have to sketch pi by 2, I will just do half of it, correct?
Yeah.
So I get pi by 2. No problems, correct? If I want to do pi by 4, it is half of this. Pi
So the
by 4.
45 degrees. Yeah.
How easy it is, right? And
Always.
you want to do pi by, you can divide pi in three equal parts also. Like, see this, right? I divide this into three parts. So this now is what? 60 each, right? I should actually, let me do it correctly. I did not do it correctly in a rush. I got something which was not right. So at least pi by 3 is, I have to divide in three equal parts. So this pi this is the pi, right? So I'm dividing it into three equal parts. Do you see how I divide this into three equal parts? Just make an arc and then two equal arcs, and there you go. This is pi by 3. You get it? I divided pi in three equal parts, and this is 2 pi by 3. Does it make sense to you?
Because it's 360.
2
By
pi by
3.
3 and pi by 3 makes us 2 pi by 3. And this will be 3 pi by 3. You see that 3 pi by 3? 3 and 3 cancel, and we have pi.
Okay.
And if I go further, then I have 4 pi by 3. Do you see how easy it is? 5 pi by 3. And this is 6 pi by 3. 6 pi by 3 means 6 goes 2 times, 2 pi. You get the idea?
Yeah.
How simple it is.
So it's 360. I see.
You see, and if I have to do pi by 6, then I have to do half of pi by 3, right? So these are equal. So you got pi by 6. You get this. You see how easy it is.
Yeah.
So radian measurements and looking at this is very simple. So let us be very conversant with using radians first. That's the whole idea for a few seconds. Is that okay? Let us say I want to draw an angle of 3 pi by, let us say, 10. 3 pi by 10. It's a vague number, right? So what will I do? Well, 3 pi by 10 really means I have to first divide this pi in 10 portions, correct? In 10 equal parts, right? So
Yeah.
do you understand? I have to multiply and divide this by 10 equal parts. That means this portion has to be divided into 5 parts, correct?
And then the other side into 5 parts too.
Yes, sir. So 1, 2, 3, 4, and 5. Done?
Hmm.
So each is pi by 10. Does it make sense to you?
Yes.
It's so easy. So
So
pi
can
by
you
10,
divide in the
2 pi by
180?
10, 3 pi by 10. Anything you can get very easily. You get the idea.
Yes.
So ultimately, this will be 10 pi by 10, right?
Hmm.
And this will be 20 pi by 10, one full circle of 2 pi.
Oh, okay.
Do you see how easy it is to work with radius? You don't need a protector now. Nobody's
Okay.
going to buy it, right? Why? So we're done with understanding radian in our Cartesian plane, basically. So we could relate very easily radians with degrees now. It is easier to write in radians than in degrees. You understand?
Yeah.
For degrees, you still need a protector. I'm telling you. If I say 150 degrees, oh my God, 150 degrees is where you'll say, oh, think about it. Correct? It is more than 90, less than 360. Oh, it's kind of difficult. Right? Anyway, but in radians, we could easily get this 150 degrees, right? How many multiples of 30 degrees it is? It is 5 multiples of 30 degrees, right? 3 pi by 6. Do you, five, sorry. 5
Oh,
multiples of 30 degrees, right?
so pi
3
by
5 pi by 6. Do you see that?
yeah.
And 5 pi by 6 basically means 1 less than pi by 6. You get the idea?
Okay.
So that is 5 pi by 6. So my acute angle now is pi by 6. Do you see how I made 150 degrees so easily?
Um,
150 is 30 times 5, right?
Yes.
30 we just figured out is pi by 6, correct?
Yes.
So we have to go 5 pi by 6 means 1 less than 6 pi by 6, correct?
Oh, okay, because 180 equals pi, and so then divide by 6 would give you 30 degrees. So pi by 6
Correct.
is 30 degrees, and multiply that by 5, so it's 5 pi by 6. And then to get one less than that would be
5 acute angle. Now, this is what we call related acute angle. So, related acute angle.
how did you find that?
180 minus 150 is 30 degrees, right? Which is pi by 6. For now, you have to convert, but soon you'll be actually getting it in radians directly. But today, since you just started beginning, you just started with radian measurements.
Mhm.
So, 150 is 30 less than 180, correct?
Yeah.
So, say 30 less than 180 means this angle has to be 30 degrees, correct? Otherwise, complete angle.
Oh, because 150 plus 30 is 180, and you want to get
Correct.
back. Okay.
And and 30 degrees, oh, 180 was pi, and to get 30, what should I do? I have to divide both by 6, right?
Mhm.
That is 30 degrees, correct?
Yes.
So, so we know this is 30 degrees, correct?
Correct.
That is, and this is my related acute angle. And pi could be written as 6 pi by 6. Pi
Yeah,
is 6.
pi.
So I
6
am,
minus 6,
I
1.
have 1 less than 6 means 5 pi by 6. Do you get the idea?
Oh, yeah, I get it. Because you have 6 pi over 6 minus pi over 6 is 5 pi over 6. That's
Yeah,
it.
one division, one fraction less. So that is how easily you can actually get all your angles in
Okay.
radian measurement. So this is just to display or to make an image of how easy it is to actually plot exact measurement of a radian angle without a protector. Does
Okay.
it make sense?
Yes, that completely made sense.
Okay. Now let's get into special triangles.
Oh, okay. Let's do it. Oh, why is it moving like this?
Don't worry. Yeah. Special triangles. We only have two special triangles, just two. So one we call as 90, 45, 45. You can write this in any order.
I thought
And
before there were 3.
pardon?
I thought there were 3 before.
Okay, don't worry. We'll make them three. How does it matter? Don't worry. So 90
Oh,
is like,
wait. I figured it out. This one's divided into half. That's why. Okay.
okay, okay. So sorry. 90 in radians is what?
90 in radians is pi by 2, right?
Yes. And 45 is pi by 4, correct?
Yes.
So this is one right angle triangle. So in this right angle triangle, we know that two sides are equal, right? Two legs
Yeah.
are equal, correct? And
Correct.
therefore, you get 45 degrees. Or since we are working in radian, we should be writing
Pi by
pi
4.
by 4. Correct. Now, if I have a dimension of this as, let me now make a better drawing here. Okay. Let's say these two sides are equal. Now, if I make one of the side as 1, then what is the hypotenuse? 1 square plus 1 square square root, right?
Yeah.
That gives you square root of 2.
Mhm.
So that becomes my pi by 4, pi by 2, pi by 4 triangle. Is it clear to you? Easy, right?
Pi by 4, pi by 4. Which, because it's 90 degrees, so the two angles have to equal to 45. I get
Yes.
that. But do we just leave the root 2 same? Like the sides stay the same, they don't turn into radians because it's not an angle.
So even if you take a general side a and a, for example, right?
Yeah. Huh.
In that case, it is a square plus a square square root. So it will be a times square root of 2, correct?
Okay.
Ratio wise, a and a will cancel and you will get sine, cosine, and tan very easily. Is that clear to you? So
A
now let's
little
look into this triangle once again. Purposely, I removed it. Don't
here.
worry.
I think it's smaller.
Don't worry. So yeah, now this is better side. So now we'll again make our triangle and we'll now work strictly with radian measurements. These two sides are equal for us and it is 90 degrees right there.
Yes.
What is the order which you have learned? Do you say pi by 4, pi by 2? Sorry, pi by 4, pi by 2? Or what order? 90, 45, 45? Or like what?
I think we say 90, 45, 45.
Right. So you could say this as pi by 2, pi by 4, pi by 4, which is same as 90 degrees, 45 degrees, 45 degrees. 40. Is that okay?
Yes.
So in this particular triangle, if legs are 1 each, then the hypotenuse is square root of 2, correct?
Yeah, because 1 squared plus 1 squared square root of that
So
equals to
from
6.
here, you get the value of sine of pi by 4, cos of pi by 4, and tan of pi by 4. These are the exact values. So sine is opposite over hypotenuse, 1 over square root 2, right? Cos is also same, 1 over square root 2, because both the legs are same. Tan is the ratio of the legs, so it is just 1. Is it okay?
Yes.
It is important to understand that normally we will not write square root 2 in the denominator. We need to rationalize it. Is that correct?
Okay.
So either we multiply by square root 2, and so we get square root 2 over 2. This is one way. We could do, these could be our values for pi by 4. Or we could use this triangle. Look at this triangle. I'm saying each side is square root 2. Then what is this side? Square root 2 square plus square root 2 square square root. Is it okay? So which is how much? 2 plus 2?
Is
4. 4 square root is 2. Do you see that?
okay.
So now you can write cos of pi by 4 is equal to sine of pi by 4, and it is equal to 2 over square root 2. We do not have to rationalize. So you could use either of these triangles for your calculations. Is that clear to you?
Yes.
So your book says 1, 1 square root 2. If I multiply each side by square root 2, what happens? This becomes square root 2, this becomes square root 2, and that becomes 2. Does it make sense? Scale by a factor of square root 2. Same triangle. But advantage is I straight away get an answer which is not requiring rationalization.
I see.
We avoid square root 2 in the denominator for answer of any question in general. Is that okay?
Yes.
Especially for IB students.
So I should use square root 2, square root 2, and 2.
Correct.
Okay. And that'll give me the direct answer of square root 2 over 2.
Correct. Sometimes in the question, 1 over square root 2 may work better because you have to multiply sine and cosine, then square root 2, square root 2. When you multiply, you get 2. Right? So it all depends when which triangle works better for you. Correct?
Correct.
Now, let me erase this and look into the second special triangle. Second special triangle comes from an equilateral triangle. So I'm just going to make an equilateral triangle, means all equal sides. Each angle 60 degrees, correct?
Correct.
60 degrees for us means pi 180 divided by 3 gives me 60 degrees.
Okay.
If I drop a perpendicular from one vertex to the opposite side, then it is going to divide these sides into equal parts.
Okay.
If each part is 1, then that means 1 plus 1 is 2. The other side was 2, right? Because all sides are equal, right? So what is going to be my altitude, the height? It is going to be 2 square minus 1 square square root, which is square root of 3. 4 minus 1. Is it okay?
Oh yeah, because you're just finding like a side length. Yeah, that makes
Right.
sense.
So now we have a special triangle, and in this special triangle, you will notice that the other angle is what? This angle is pi by 6, correct?
Pi. Why is it pi by 6? Oh,
Because
because
total is, yeah, pi by 2 minus pi by 3. Common denominator of 6. 3
pi
pi
by
minus 2 pi gives you pi by 6, right? It is 30
yeah.
degrees, 60 degrees, 90 degrees triangle. Is it okay?
Mhm.
So it is pi by 6, pi by 3, and pi by 2 triangle. Neat.
Yes.
Clearly, we have the value of sine pi by 6.
So with the other angle on the other side, like the
Yeah,
other angle,
yeah.
that would still be pi by 6,
Yeah,
right?
yeah, yeah. So same triangle can be used for both. So we don't need the third triangle. Do you get the idea?
Okay.
Only thing is you have to look from the other side. And see now, let's look into sine pi by 6. So purposely, I have taken the other side. Say sine pi by 6 means looking from here, right? Opposite is half, 1, right?
Mhm.
So it is half. Cos pi by 6, now adjacent is square root 3, right?
Yeah.
Hypotenuse 2. Tan, opposite is 1 over adjacent square root 3. Does it make sense?
So you looked from the top apex angle, the
Yeah,
green one right here, and then you looked down, and then you said
opposite. Sine,
the tan is opposite over your adjacent, and so the
yeah,
opposite is 1, and your adjacent is root 3.
correct.
Okay. I thought that
Now,
was an
yes,
equilateral triangle, so wouldn't it have just been 2, 2, and 2?
yeah, half of 2 is 1, right? So this is total is 2. So
So,
this
oh,
half is
the
1.
height is root 3. I
Yeah,
see.
height is root. So this equilateral triangle is 2 here, and 2 at the bottom also, base, right?
Hmm.
Half is 1, correct? This is
Got it.
1.
I got confused.
Exactly.
I thought the height was the actual side, but I didn't realize it was the height.
Yeah, height. So we are doing 2 square minus 1 square, square root. 4 minus 1 square root, which is square root of 3.
Hmm.
Is that clear?
Yes.
Now look here. Now let us calculate what is the value of sine of pi by 3. Can you tell me?
Sine of pi by 3. So pi by 3 is sine 60.
Don't convert now.
Oh, should I just use my calculator in
No,
radians?
no, no. Look at the special triangle.
Oh, sine of pi by 3 is opposite over hypotenuse, so it's root 3 over 2.
Cos pi by 3.
Cos pi by 3 is adjacent over hypotenuse, so it's 1 over 2. And
Tan pi
then
by 3.
tan pi by 3 is opposite over adjacent, so opposite is root 3 over 1, which is root 3.
Very good job. Now see the beauty. Do you see these two values are same?
Yes.
This is called cofunction identity.
Uh,
So what is happening is that, in a right angle triangle, if I look from the other side, opposite becomes adjacent. And adjacent becomes opposite. Sine
uh,
becomes cosine, cos becomes sine. Do you get the idea?
yeah, that's so easy.
Cofunction identity.
You just have to like switch them. You switch sine
Yeah.
and cos.
So what we realized just now is that sine of, I'm writing in degrees, 60 should be equals to cos of 30, right?
Yeah.
We are working in special triangles, but it could be sine of 20 will be equals to cos of what? 70. Complement. 90 minus 20.
Yeah.
You get the idea? This is
Yeah.
called cofunction identity.
Cofunction identity.
Sine 90 is cos 0 is sine 90. You get the idea?
Hmm.
Cos 90 will be sine 0, correct?
Yeah.
Cos 0 is sine 90. 90
Okay.
minus theta. So I could write cos theta equals to sine 90 minus theta, and sine theta equals to cos 90 minus theta. Either way, it works. In quadrant 1, all are positive. You get the idea. This is
Yeah.
called cofunction identity.
I see.
So make a note, cofunction identity. And also, do you get this triangle, special triangle? Pi by 6, pi by 3, pi by 2?
Yes.
Very good. So I'm going to clear the screen now. Let me rewrite cofunction identity.
And it's only with the sine and the cos, right?
Everything.
Even the
And
tan?
also, yeah. Let me just make one neat diagram for you. So let us say this angle is theta, right?
Yeah.
In general, that angle will be 90 minus theta. If you're working in radians, then you have to write pi by 2 minus theta. Is that clear to you?
Yeah.
Okay. Now, let's say, let me just label this as ABC. So in this triangle, sine of 90 minus theta is equal to cos theta. Cos of 90 minus theta equals to sine theta. Tan of 90 minus theta will be what? Cotangent theta. Cot is reciprocal of sine. You get the idea. You have not done reciprocals yet, right?
No, I think this is the first time we're seeing them.
Okay. So tangent is a ratio of opposite over adjacent. Cot is adjacent over opposite. Is it okay?
Yeah.
That is all. But anyway, sine cosine, you got it, right? So
Mm.
if you're using radian measurements, clearly you're going to write this as sine pi by 2 minus theta is cos theta. And cos of pi by 2 minus theta is sine theta.
I'm a
So we are
little
working in quadrant 1. Yes.
I'm a little bit confused on like the subtracting the theta. I don't get why we're doing that.
Okay, let's do it again. Look at this triangle. What is the sum of all the angles? If my what is angle B equals to? Angle B is 180 degrees minus angle A minus angle C, correct?
Yeah.
180 degrees minus theta minus 90, which is 90 minus theta. So angle B is 90 minus theta. Do you see that now?
Yeah. Okay.
Always in a right angle triangle, sum of these two should be 90.
Oh, okay.
Correct?
Correct.
Theta plus 90 minus theta is 90.
I
So
see.
straight we get 90. So it's a co-function because if you look from this side, this is opposite, right?
Yeah.
But from this side, it is adjacent. So the
Oh,
ratios switch.
okay.
Very important identity, co-function identity. So that is extremely important. And you do have so many relations with co-function related kind of identity, which I'll just teach you in a minute. Okay. So did you understand all this, which I am talking about?
Yes, so far.
Very good. Now let's get to your page in more details. In your page, you see your teacher has written reciprocal of sine cosine. So those are cosecant, secant, and cotangent. Do you see that?
So secant is just your hypotenuse over your adjacent, and
Yeah.
then cosine C. What is that?
Okay, I'll
Cosine.
write down. So here is my beautiful circle, and now let's work with this.
Okay.
Let's take any point on the circumference, and let's call this point P as XR, X coordinate and Y coordinate in general. Let R be the radius of this circle. Is that clear to you? And the
Yeah.
angle which it makes with the positive X axis is theta. Now, in this case, let us define all our trigonometric ratios. Clearly, if x and y is the coordinate, that means if I drop a perpendicular, then horizontal distance from O to, let's say, Q will be x, and the vertical distance will be y, correct? So now, what is sine theta equals to?
Sine.
Opposite side y over r. What is
Okay.
cos theta? X over r, and tan theta is y over x. Is that clear? Opposite over this. You remember SOHCAHTOA? Sine is opposite over
Base.
hypotenuse. Cos
Oh,
is
sine.
adjacent over hypotenuse. Tan is opposite over adjacent. So I'm writing it in a different, shorter way, showing you the ratios for each trigonometric ratio. Now, these are called primary trigonometric ratios.
Yes.
Reverse of them is called secondary. So, secondary means 1 over sine. So, and the name is cosecant. So, we write cosecant. And reciprocal means r over y. Do you see that?
Hypotenuse. Oh, so you just take your hypotenuse over your opposite.
Secant r over x. Cotangent x over y. So these are called cosecant,
Yes.
secant, and cotangent. Remember one thing, all these trigonometric ratios are written in lower case, no capital letters.
On our calculator, would you be able to calculate cot?
No. 1 over 10. 1 over 10.
Oh, okay.
So cosecant is 1 over sine theta, secant is 1 over cos theta, and cotangent is 1 over tan theta. Is that clear to you?
Yes.
So calculator has 3 primary trigonometric ratios. You have to do reciprocal of those to get the secondary trigonometric ratios, right? Unnecessarily, why should we have so many keys, correct? No need. Does it make sense?
Yes.
So that means trigonometric ratios, now you know primary and secondary. The second part is looking at the value in different quadrants. So let's get there now, okay? Now look here. We'll understand the cast rule before moving forward.
Okay.
Let me again sketch a circle here and a point on a circle. We are saying is r units away and my point has x and y coordinate values. You're seeing that sine is basically the ratio of x and r, correct? Cos theta is the ratio of y over r, and tan theta is the ratio of y over. Oh, sorry, I wrote it wrong. Sorry. I wrote it wrong.
Opposite meaning y over x, right?
Yeah. Sine theta is the ratio of y over r. Cos theta is x over r, and tan theta is y over x, right? Now, it is important to understand that r is always positive. R is always greater than 0. Is it clear to you? Radius.
Okay.
Radius cannot be negative. It's considered to be positive. So it is positive. Is that clear? But x and y could be negative, right? So if you look into different quadrants, let's say this is our quadrant 1, this is quadrant 2, here we have quadrant 3, and then we have quadrant 4. So you know x and y, they are positive here, correct?
Yes.
Here, x is negative and y is positive. In this case, both are negative, correct?
Yes.
In this case, we have positive and negative sign, correct? X is positive, y is negative in quadrant 4. Now, you can clearly see that the sign of sine theta depends on y, right? So wherever y is positive, sine will be positive. Clear?
Oh, okay.
So here, everything is positive. Let me write A, all positive. In quadrant 2, what is positive? Y value, only y value. So sine is positive. In this case, both are negative. That means tan will be positive because negative divided by negative is positive.
I see.
And in the quadrant 4, x value is positive and therefore cosine is positive. So we have our cast rule. Do you see the cast rule now?
What does so I understand, so in the C part our cosine value is positive, and our T, our tan is positive, and S, our sine is positive. But for A, does that mean anything is positive because both
All are
positive?
positive. Aim is all.
Okay.
All of them, correct? So clearly, if sine is positive, its reciprocal cosecant will also be positive, correct?
Yes.
If cosine is positive, reciprocal secant will be positive. And if tangent is positive, then the reciprocal cotangent will also be positive, correct?
Yes.
So that is clear. Is that okay?
Yeah.
So we got this. So cast rule is clear to you now?
Yes.
Very good. We are going to use it many times, so don't worry about it. It will come
Okay.
again and again. Now let's look into the angles ratios for different conditions. Now let's again, yeah, make it smaller. I don't need it. Make it small. Make it small. Reduce. Very good. Now look here. When you let's try to understand what is an angle.
Okay.
So to make an angle, we assume that the initial arm is along the x-axis. This is called initial arm.
Okay.
We assume that both the arms are together, one over the other to begin with. Is it okay? Then we start opening it the other arm. We keep one fixed. Initial arm is fixed.
Mhm.
Then we open the other arm, and this is called the terminal arm.
Oh, I remember this from grade 10.
Yeah. So terminal, wherever you stop opening, terminate, that is the position, terminal arm. And the
Okay.
angle is called theta. It is positive when we do counterclockwise. Is that clear to you?
It always goes counterclockwise?
Counterclockwise is positive. If you go clockwise, it is negative.
Okay.
Convention. So counterclockwise, positive angle. Right. Now, we also say if the angle is, if angle theta is less than 90 degrees, it's called acute angle, right? Acute angle means less than 90 degrees. Correct? 90 degrees is right angle.
Yeah.
Now, we have seen that all these trigonometric ratios are periodic in nature. So that means if we know the set of values for quadrant 1, we actually know set of values for all the 4 quadrants because except for the sign, magnitude is always same, correct? Sign could be positive or negative, correct?
Correct.
Now, main point is if I am going through a circle, x and y value, if I define x, y, and r on a circle, in that case, sine theta is the ratio of x over r. Now, if x value is same, then sine theta will be same, correct? So you
Correct.
see that x value is same at 2 places. Let me just make a triangle here. Okay. Uh, let's consider these two positions. Angle theta and angle theta. Is it okay?
Okay.
Now in this triangle, if you look for it, these two triangles are congruent triangles, right? If R is same, they are congruent triangles. At
Mhm.
this point, the value of P is xy. So on this side, the value of P dash, let me write, in quadrant 2, will be what? Minus x and y, because x is negative, right? Because we are in quadrant 2. Magnitude is same. If you draw a circle with radius r, then on a circle, because of its symmetry, the point will be minus x and y, correct?
Yeah.
It really means that the sine value will be same for this angle. We always write the angle in terms of principal angle. So let us understand what is the principal angle. Principal angle is measured from the initial arm like this. That is my principal angle. You understand?
Oh, okay. So it's like kind of your altitude?
So the angle, you rotate it up to this point counterclockwise like this, up to this point. So let's call this angle as phi, right? So this is my angle. So what is the measurement let's say when principal angle was theta, the acute angle, then sine theta was x over r, right?
Okay.
From this triangle. Now, what is sine of phi? If you look at this triangle, we form this triangle. What is the opposite side? Y,
Uh,
right? And
why? Yeah.
radius is r. So still it is, oh, sorry, sine was y over r. So not x, y over r. So y over r in both the cases. Do you see that?
Okay.
So it is same.
I see.
Let's do it again. Let's do it. So you have understood what is the acute angle? And now we'll begin from there once again.
The acute angle is like when you do the Cartesian plane and then from the initial arm you bring it up and you stop. That's your acute
Right.
angle?
Okay. So let's take a point P. In general, it is xy, right? And the radius is r, or the distance from origin is r. And if I rotate this and come to this quadrant so that I make an angle, let's call this angle as alpha. You understand this alpha angle? You remember this alpha beta?
We haven't used that notation yet,
Yeah,
but
we'll use that. Let's
okay.
write down.
Gamma. I know that. I know gamma.
Okay. So these are commonly used: alpha, beta, gamma, theta, and phi. Phi is used in many cases for null set also in functions. Phi is very important. Phi. So these we use for angles, Greek symbols.
Okay.
So and alpha and beta we use for acute angles also.
Okay.
Now let us say this angle is alpha, and this angle will be how much? If that is alpha, this will be pi minus alpha, right? Because total is pi.
Oh yeah, because the total is 180, so it's and 180 equals pi, so it's pi minus your alpha, which gives you the red angle.
And this point will be what? X becomes negative, but y remains the same. You see that?
Yeah.
Radius is also the same. So in this condition, what is sine of alpha equals to in relation to sine of pi minus alpha? They are same, correct?
Sine of
Because
alpha in
both
relation
are y over r.
pi minus alpha is just your this angle, right? Can you
So
see that?
then we can make this triangle. So when you look at the triangle which is on the left hand side, the angle formed by the terminal arm actually is pi minus alpha. You get the idea?
Okay.
That is how we read it. And in that triangle, if I look from the side, that becomes the opposite side, and hypotenuse is r. And so y by r.
Okay, I get it. So the arm, like the arrow that we've created, what is that called? Is that like a terminal arm or is that a
This is still a terminal arm. Yes. New position. So pi minus alpha is the angle. It is called the principal angle. This angle is the principal angle. All the time, when you measure from the rotation, I should write counterclockwise rotation from positive x-axis
always?
is principal angle. So remember, principal angle, let's call principal angle theta, it is always between 0 to 2 pi.
And 2 pi is 360.
Yes. So that is a principal angle. So in four quadrants, we look into the angle like you say 0, 90, 180, 270, 360. Correct? Again, you could go 360 plus 90. But what we say when we talk about principal angle, we again start with 0, 90. So we are only talking about this, right? So the angle for any triangle formed in the Cartesian plane is between 0 degrees to 360 degrees. If I see cos of pi minus alpha, then this value is what? The x value now is negative. So negative x over r, right?
Yeah,
Focus in this triangle. So which is negative of cos alpha. Do you see that? Because in this quadrant, first quadrant, all are positive.
I see.
Here only sign is positive. So whenever we talk about pi minus alpha, we are in quadrant 2. In quadrant 2, only sign is positive. Therefore, for pi minus alpha, you are in quadrant 2, only sign will be same, others will be negative. So I could also write this as tan of pi minus alpha equals to minus tan alpha. Because in second quadrant, tan is also negative.
Negative.
Do you understand the concept?
So far, I understood like the part where this this orange and red line is like your principal angle. No,
Yes,
is it your principal angle? Yes.
yes,
Or,
yes.
but the terminal angle is like the green line where we
No, no,
write
no. Okay,
R.
let me go through it again. Don't worry. Let's do it again. So as I draw with different angles, so I'm drawing a straight line, basically means 180 degrees, correct?
Correct.
Just for reference, I've drawn vertical line means 90 degrees or pi
Okay.
and pi by 2 we're talking about.
Right.
Now we are drawing one angle in quadrant 1. So it is in quadrant 1. All are positive, right? All are positive. And I'm
Yes.
treating this angle as one of my angles as alpha.
Okay.
Any angle measured counterclockwise, so I'm making an arrow here, counterclockwise from the initial arm, which is positive x-axis, principal angle. So this measurement of principal angle is alpha. Is it okay?
Okay.
Now, I move this arm and come to this position so that the angle now becomes alpha with the horizontal line. It's like angle of elevation. You see that?
Yeah.
So in this case, the angle in between from here to here is how much?
It
It
would be
is,
pi minus alpha, right?
yes. Now the principal angle for this arm is pi minus alpha. So position here is P with coordinate point X and Y. Position here has changed to like P dash with coordinate point minus X and Y. R value will be same because R is equal to square root of X square plus Y square, which is positive. You get the idea, right?
Mhm.
Always positive. Now, you see, now do you understand?
Yeah, I get it now. So
Yes.
our alphas on both sides are the same value because
Correct.
it's the y value, right?
Correct.
That's the same. So that's why the alphas stay the same.
Yes.
Okay, I get it.
Now, we also see that cast rule. Sign is positive in quadrant 1, right? So in quadrant 1, whatever sign value you get will be positive, right?
Yeah.
So what is sign of pi minus alpha? Pi minus alpha will be the y value divided by r value. Both are positive. However, what is cos of pi minus alpha? The x value has become negative. Do you see that?
Oh, I see. Because
Similarly, the tan of pi minus alpha will be y
negative.
over x. Y is positive, but x is negative. So it becomes negative.
I see.
That is why when we relate them to related acute angle alpha, sine is same as sine alpha, right? So this is equal to sine alpha, correct? But this is minus cos alpha because cos alpha was positive. Similarly, tan alpha was positive, but we are looking for a negative value. So I have to do negative of that.
Okay, so our principal angle is basically like our original angle, and then we move, and then we get our new like terminal angle, and then you have to find like your related acute.
Yes,
And your related acute, if it's in the sine quadrant, then your cos and your tan will be negative. And then if it's if you're finding like your sine value, it'll be positive because your y is still positive, and basically the y over r is the only thing you need for sine. And because you need x values for cos and tan, it'll be negative cos alpha and negative tan alpha. I got it. Okay,
Good
this makes so
job. Good job. So let's take a concrete example. Let's talk about sine of, let us say, pi by 6. What is sine of pi by 6 equals to?
pi by 6 is 30 degrees.
Yes, which is half, right?
Half,
So
yeah.
special triangles. You have to recall your special triangle. Sine pi by 6 is half. Now, if I think that alpha, what is sine of 5 pi by 6? Tell me.
5 pi by 6 is pi pi.
Pi minus pi by 6, right?
Oh yeah, it's pi minus pi by 6. So it's 6 over 6 pi minus
Which
pi.
is same as half. Which is
Yeah.
same as half. You get the idea. You get the idea, right?
Yeah,
So,
because it's pi by 6 is the answer, Steve.
yes. Let's say cos pi by 6. Cos pi by 6 is square root 3 over 2, right?
Yes.
But what is cos of pi minus pi by 6? Let me put like this. It will be minus square root 3 by 2 because we are in quadrant 2.
Oh, okay.
You get the idea?
Yeah.
So that is the cofunction. That is the function 180 minus. This is what they are trying to explain here.
So does the rotation, so the like the yellow arrow that we've drawn here, like
Yeah,
when they give you a question,
yeah,
they'll indicate like the rotation, and so we have to rotate it as much as what is best fit. So because we know that this is 360, this is 180, this is 90, and you just keep going, so you keep rotating it like
yes,
that,
yes.
rotating the direction of which it's like best.
Counterclockwise, yes. Now let's look into it once again.
Okay.
Now we are going to move from second to third quadrant.
Do
So
you want
how
me to go down the page?
you can, no problem.
Oh, I think okay,
Yes,
we
don't
can
worry,
go.
don't worry, don't worry. I'm just using as a reference so that I know exactly what you need to learn, right?
Okay.
So let me again draw our last diagram, but now ending up in third quadrant. So now this is my angle alpha. Vertically opposite angle will be alpha, correct?
Okay.
What is this? This is my principal angle. Look here. From initial arm to terminal arm. So this angle is how much now? Pi plus alpha, right?
Why is it plus? Oh, okay. Because you're going minus and then minus, so that it's
Pi
plus.
plus alpha. You go pi and then alpha, right? Let's redo. Let's redo.
Okay.
So we have an acute angle alpha. Acute angle means you are in quadrant 1, correct?
Correct.
So vertically opposite angle is also alpha, right? These two are equal angles. In any triangle, vertically opposite angles are equal. Now, how much is this angle? From here you go pi and then alpha more. Do you see that? So
Oh,
it
so
is,
it's pi plus alpha.
does it make sense? Easy.
Yes.
You have reached from quadrant 1 past 2 into 3. We'll go to 4 next time. In quadrant 3, tell me what is positive.
In quadrant 3, only tan is positive, and
Therefore, if I write tan of pi plus alpha, I should get equal to plus tan alpha, same as tan alpha. But if I want to find what is sine of pi plus alpha, it will be negative of sine alpha, and cos of pi plus alpha will be negative of cos alpha, because sine and cosine are negative in quadrant 3. Does make sense to you?
yes.
So once you know the angle in quadrant 1, you can find its image on any other quadrant and find the angle just
You just have
by,
to it's vertical opposite.
yeah, clear? So
Clear.
we have another set of identities for you. when we are talking about the angle pi plus angle. Do you see that? Now let's do the last one. The last one here relates to ending up in quadrant 4.
which
So
is
we'll
cosine.
begin with 1, 2, 3, and now in 4. That basically means that if I have an related acute angle alpha, I go through the whole circle and leave alpha. You see that? I went through the whole circle and left alpha. So how much did I go? Full circle is 2 pi minus alpha.
Oh, okay, I see.
So cos of 2
Because
pi minus alpha is positive cos alpha. However, sine and tan will be negative because we are in quadrant 4.
which is only cos is positive. So
Does it make
tan
sense?
also be negative. Yeah. Oh, so I see what they're writing in the brackets now based on like 2 pi minus alpha. So basically
Yeah,
what they're
yeah.
oh, so like if they were to give us like for example instead of alpha like a degree, like
Yeah,
cosine, like your angle will be like 200 something at that point.
correct.
So you can just go 2 pi minus 200 and you get the
Correct.
cos of that and that
So
gives
if
you
I say what is cos of 300 degrees, right? You say
yeah,
cos of 300 degrees is cos of 360 minus 60 degrees, correct? Which is
correct.
same as cos of 60 degrees. And cos of 60 degrees is half
I see.
using special triangle. Do you get the idea?
Yeah,
That is
because
your
60 minus 300 is 60, and so that's your related acute, and so then you just that's what you find as a value,
correct. So whatever angle is given to you, find the related acute angle.
and then do it.
Yeah, and also when angle is given to you, you know the quadrant. So quadrant gives you the sine, related acute angle gives you the magnitude. Clear?
Okay.
Is that clear? So
So
let's
the
clear this off. Let's clear this off. Now we have gone. Let's say cos of, let us say, we'll work with our special triangles, right? We have 225 degrees. So what is 225 degrees? 225 degrees, as soon as it comes to your mind, you know very clearly it
what?
is, this is 270 and this is 180. So we are definitely in quadrant 3, right?
Oh, okay, yeah, that makes sense.
So quadrant 3 cos means negative value, put negative there.
Okay.
Now you have to see how much did you add to 180 to come to this point. That is my related acute angle.
Mhm.
Acute angle is the angle which terminal arm makes with the horizontal x-axis.
So wouldn't this just be pi minus 225?
So how much? 225 minus 180 is how much? 45, right?
Yeah.
So it is equals to cos of 45 degrees, correct?
Yes.
And cos of 45 degrees 1 over square root 2.
But
Or you
wait,
could write square root, or you could write square root 2 over 2, right? Minus. So we get
oh,
the exact value.
because then it's like as we did it here. So this is 2, this is root 2, and this is root 2. So then if we're trying, they're asking us to find only like cosine, or you're asking. So cos of 45 degrees equals to your adjacent over hypotenuse.
Yes.
So that equals to root 2 over 2. Can I get that?
Very good. Now look into this definition of related acute angle. Related acute angle is the angle that terminal arm makes with x-axis. Always consider positive. It is always between 0 degrees to 90 degrees. Acute angle means, and therefore all the trigonometric ratios will be positive for the given acute angle. So we get the magnitude, and from the position we get the sign in which quadrant you are. Is that clear to you?
Yeah.
Another
So
example, let's take
Okay.
We have to
So
now find what is cos of 300 degrees. Tell me.
okay, so cos of 300, meaning it'll be in the fourth quadrant because 270 is the bottom and it's greater than 270.
So positive sign, correct? Fourth quadrant, positive sign, correct?
We're looking at cos, yes.
And you have to find related acute angle. How much is this acute angle?
So this, because it'll be 2 pi minus 300.
360 minus 300, 60 degrees.
And so then our special triangle, if we look at it,
Here it is, here it is.
oh, I didn't see that. So our special triangle means that this is pi over 6.
Pi over
So
3, pi over 3, 60 degrees.
oh, I thought it was 30 degrees. Sorry.
Sorry.
Pi over 3. So cos means adjacent over hypotenuse. So your adjacent is 1 and your hypotenuse is 2.
Correct. 1/2, right? Clear. Is that simple, right?
Yeah. And so when they're saying to do this with radians, all they mean is just to use the 2 pi minus.
Radian is so simple. I'll do radian just now. Degree was difficult. Oh my God, degree is very difficult.
Yeah.
Look here. You will see. Let's find tan 5 pi by 6. Okay.
Okay.
So in which quadrant we are? Tan 5 pi by 6.
5 pi by 6, I believe we would be in, because it just equals to pi by 6, and pi by 6 is 30 degrees. So
No, don't think like this. 5 pi by 6 means you have to think like this. This position, think like this 6 pi by 6. Do you see that? Pi is 6 pi by 6, correct? You are only 5 pi by 6. That means one less.
yeah.
One less is 5 pi by 6. Do you see how easily we made it? So this is the acute angle pi by 6. In radian, you do not have to think. It is so easy. You are in quadrant 2. Quadrant 2 means negative sign. Do you see that?
Yeah, of tan. I see that.
And negative sign of tan what?
It's pi by 6 is your answer for like the.
Now look at the pi by 6. This is my pi by 6, right? What is tan pi by 6? Opposite over adjacent. That is pi by 6. Opposite over adjacent. Do you see that?
Yeah.
1 over square root 3 with a negative sign because you are in quadrant 2.
This is so much easier than last year because this didn't make sense at all. And now I actually like get it.
Now look here. We'll do another one. Let's say
Okay.
sine. We've not done sine for a long time, right? Sine 4 pi by 5. No. 5 pi by 4 I wanted to write, sorry.
Okay. So we know that the 180 has to be 4 pi by 4.
Yeah.
1
So
over. So
yes.
you're in quadrant 3. And so that equals to pi by 4. And pi by 4 is just 180 divided by 4, which is 40.
This triangle. Pi by 4 is this triangle.
Oh my
1
God.
over square root 2. Done. Do you see that?
Yeah, it's so simple.
You get the idea?
For tan, which is like your opposite over your adjacent, and regardless of which one you pick, it'll still be your opposite 1 over root 2 negative.
Correct. So
Because
not difficult, right?
no, this isn't actually that hard as I thought it would be.
Yeah. Let's write this 25 pi by, I don't know, 6.
Do we
Cos
have
25 pi by 6. Tell me now, answer. Which quadrant you are?
25 pi by 6, meaning that
So this is like, you see,
pi
this
by
is
6.
6.
I think
You
it's
count like this.
I think
This
it's
is 6. 6, right?
Yeah.
12, 18. Go multiples of this 6 only, right? Do you understand?
Oh.
So this is 12, this is 24, and 25 will be here. Done. 25 pi by 6.
Oh, so you just go 6, and then you go 12, and then you go again
So
24.
you can go by 12s also, right? 12, 24, and then 1 pi. 25.
Oh.
So since you are in quadrant 1, we have positive value, And what is cos pi by 6? Go to this pi by 6 triangle and give this angle square root 3 by 2. Done. Do you see how easy it is?
Yeah.
That is how you have to do. You get the idea now.
For like any sum, you just do
Any
this.
angle. Any angle. You do not have to do any calculations. This is your radian. Easy. Sine 10 pi by, if I write 5, it will be 16, let me write, right? 5 pi by 5. Oh, 16 pi by 5. Okay. We
Okay.
don't have the exact value, but
5
we
by
can.
5.
So 5, 10, 15. Do you see that? 5, 10, 15? You land
5,
up here, quadrant 3. Is that okay? So we
5.
know this is negative value, correct?
Wait, so 5, you start from 90 to
No. I
80?
count like this. Pi by 5, right? So we are dividing the whole pi in 5 equal parts. This is pi divided into 5 parts. So we say 5. This pi is divided into 5 parts, right?
Uh-huh.
5. Now 5 more. 10,
10.
15, and 116. So I go pi by 5 more. You see that? But
Uh,
in the quadrant 3, this becomes 16 pi by 5. You see that?
I see. So you basically went from your x-axis to your other side of the x-axis, which was
5,
5.
5, 5, 5. Multiples of 5 you
And then
go.
the next negative side, so you go, that's another 5, so that's 10. And then you went another one, which was 15, and then you went one more
One
down.
more. 5 by 6, 5 by 5 more. Landed
Pi,
in quadrant
and
3.
that just goes to pi by 5, right? Is your
Yeah, so we get
relationship.
minus sine pi by 5. Do you see how I wrote in acute angle?
Yeah.
Sine 16 pi by 6 is minus sine pi by 5. Simple as that. So I have
Except,
related this, I have written this angle in the form of acute angle. This is related acute angle.
yeah.
You can use calculator to find this angle and get some approximate answer to 3 significant figures, for example. Does make sense?
Yes.
So it's that simple. I mean, let's go for something, right? Let's write 100 pi by whatever, right? 6. Okay. Just
Yeah.
because we want some exact values. So clearly, this is a very big number. Why? When I go from here to here, I know it will be 12, right?
Yes.
So 12. So 100 divided by 12 is how much? You
100
can think
divided
like
is 25 over 3, or 8.3.
25. So 25 full circles. 25 full circles.
That's a lot.
No. I mean, 25. What do you get? You did something wrong.
25 over 3.
No, 100 by 12 is how much?
100 divided by 12 is 25 over 3, or 8.3.
8. So 8 full circles, right? So when you do 8 full circles, you get 96, correct?
Correct.
96 means 4 left. 4 by 12. Is it okay? So ultimately, from here to here, it is 6, correct?
Mhm.
You are on the 4th one. That means you are somewhere here, correct? Because this is 3, this is 4. So that will be my terminal position in quadrant
2.
2. And I'm looking for cos, so I'm negative. Negative cos of acute angle 4 by 12. Or I could simplify and write this as cos of 1 over 3. Is it okay? So pi, I forgot to write pi. Pi by 3. 4 pi by 3. Let's redo it. Let me clear all and then do it. So we'll again do the same question. Cos of 100. Oh, 100 pi by 6. Is it okay?
Yeah.
It means I have to go round and round. So how many 12s do I go? 8, right?
8.
100 pi by 6 is kind of like this. Think about 100 as 8 times 12 is 96, right?
Mhm.
So this is a whole number, right? Cos of 96 is 8, right? 8 full circle and then 4 pi by 6, correct? So this means 8 circles. You go 1, 2, 3, 4, 5, 6, 7, 8. Okay, done. And then you do 4 pi by 6, right? So there are 6 total divisions. This is 3 pi by 6. 4 will be here. So now we have reached 100 pi by 6. You see how we reached? And we are in
Yeah.
quadrant 2. Means cos is negative and it is same as cos of 4 pi by 6, which can be simplified as minus cos 4 pi by 6. We are done. How much is left? Acute angle 2 pi by 6, correct?
2 by 6, yeah.
So 2 pi by 6 is the acute angle. So minus cos pi by 3. Oh, sorry, I want to write pi by 3. I'm still writing. Pi by 3. Yeah. You get the idea?
Yeah.
Uh, so 4 pi by 6. You could simplify this minus cos 4 and pi simplifies as 2 pi by 3. Is that clear to you?
Yeah.
So that is my principal angle. So how much is left here? 1 pi
There.
by 3 left, correct?
Yeah.
So this should be equal to minus cos pi by 3. Does it make sense to you? Look
Yes.
at this pi by 3.
And so the cost
1
of
and
that is
2.
1 over 2, negative 1 over 2.
So that is how you calculate your angles. This is
Yes.
complicated, but this is not that complicated. You get the idea?
Yeah, so you just went 100 minus 6 and you got 96?
We should figure out how many circles did we go through.
Yeah.
So multiples of 6 will help you, rather 12 will help you to go for full circles, correct?
Correct.
So when you do 100, divide by 12, will give you 8 something.
Yes.
So we have gone through 8 full circles. These are 8 circles, correct?
Correct.
After that, 4 pi by 6 left because 96 plus 4 pi is 100.
Ah, I see.
So you went 4 pi by 6. So you went more 4 pi by 6. Left was 2 pi by 6. Acute angle. 2 pi by 6 is same as pi by 3. So my acute angle alpha is pi by 3.
I see.
That
So
is
you
how I calculated.
so you basically figured out that you like 100 divided by 12 because we know that we go 6 and then this is 6, so that's 12 total.
Yes.
And 100 divided by 12, which is 8.
Yes.
And then how did you get the 96 though? That's what I didn't understand.
96 how I get? Oh, I did the reverse calculation. When I multiplied 12 by 8. 96. So I
Oh,
wrote 100 as 96 plus 4 to explain you.
I see. Okay, and then
This
from
was
there
6.
you got 4 pi by 6 because we reached uh 3 pi by 6 and it was one more.
Yeah. So 4 pi was left. We already did 96 pi by 6, right?
Oh, okay.
96 pi by 6 were full circle. So we came back to x-axis. And then we again started to reach 4 pi by 6.
And so 4 pi by 6 showed us that we were in the second quadrant because the top was 3 pi by 6 and then the x-axis on the left side value was 6 pi by 6. And so we knew that was 4 pi by 6. And so that gave us 2 pi by 6. You reduced it, which got you pi by 3. And then you used this triangle. Okay, I understood where that came from. Because you just have to use the multiple of like 12. So like if we had like 5, then you would go 5, and then you
10.
go 10, and then you go 100
Easy.
divided by
10
10.
is easy. Yeah.
Find your
Full
radiation.
circles.
Okay, that makes so much more sense.
So basically, you realize that we actually got the exact values or in terms of related acute angle without doing much calculation, just by simple logic, rotation.
Yeah.
So that is what all this exercise is all about. The whole pages. Now you go through your pages, they will make a lot more sense to you. You can go through the next page. Let's do
Yeah.
this exercise, right?
Okay.
Enlarge any one of them. We'll do them. You do them in seconds, correct? Enlarge
Okay.
any one of them. Okay.
You
Now tell me, can you read example 2 and answer?
okay, so cot means that it's 1 over tan
Tan.
theta.
Yeah, 1 over 10.
And so this is saying 2 pi over 3. And so basically we know that 3 pi over 3 is your pi over on this side.
Yes.
So when you go from there, you have 2 pi over 3, which is like 1 less. So it's
1
pi
pi
over.
by 3 less, right? So
And
this
then
is equal
you can
to
use your double triangle.
minus cot pi by 3. You understand?
Yeah. And
Which
then
is
you
kind of reciprocal of tan, right? So you are going
1
to use
over
your special
negative.
triangle. Yes, use your special triangle. Pi by 3 is this angle, 60 degrees, and the
Yeah.
sides are this. You soon
Well,
remember them, don't worry.
1 to root 3.
So square root 3 over 1 is tan. This is reverse. So minus 1 over square root 3. Is
Root
it
3. Yes.
reciprocal of tan? Do you get the idea?
I understand. Oh, you
5
can
pi by 4. 5 pi by 4 will be in which quadrant?
5 pi by 4. So we know 4 pi over 4 is the pi, so it's in the third quadrant because that's 5 pi over 4. And you know that it's 1 pi, what it's pi over 4 as your related acute. And so you use your um root 2 to root 2
Yeah, yeah, yeah. Yeah, yeah.
triangle, and they're asking for sine, which means that it's negative because it's in the third quadrant, and that means that
Good job.
tan is.
Perfect. Perfect. If you solve like this, you're done. Very good. Now, next, last one. Minus pi by 6 means you're going like this. So you are landing in quadrant 4, correct? Minus pi. Go clockwise. You get the idea?
Okay.
Now tell me, C. Secant minus pi by 6.
Okay, so you know that 2 pi would mean that it's
Minus
well,
pi. So just go clockwise.
oh, so would it just be
Clockwise
pi?
pi by 6. No, no. It's straight.
It's the same thing?
So you have my secant minus pi by 6 means you will go clockwise pi by 6. Done.
Oh,
Minus means clockwise.
I see. And so
So
our
you
related,
land in quadrant 4. So you get a positive value. Do you see that?
yeah. And so our
And use
related is
pi
just,
by 6 is this angle, correct? And this is
oh, I
square root
see.
3 and this is 2. And secant is reciprocal, right? So 2 over square root 3. You get the idea.
Oh,
Hypotenuse over the adjacent side.
because secant is just the
Cos,
reciprocal of cost, right? So it's
yes,
positive in that one. So it would just be the reciprocal. So since this was supposed to be opposite, adjacent over hypotenuse, then your adjacent was supposed to be root 3 over 2. But you
correct.
just take the reciprocal, so it's 2 over root 3. This is so simple.
Do you see the logic now?
Yeah, I
Watch
see.
your pages and then it'll be so easy for you. You don't have to remember any of those formulas which are
Yeah,
given in those pages. No, no, no. Don't
you have
remember.
to use the thing, this special triangle, and then you have to just relate
Logic.
it to what's left
Cast
over.
rule. Yes.
And then just make sure that you know like which either cosine, sine, and tan where they are like positive and negative based on their quadrants, and you just go A S T C.
Correct.
You pass, but you have to go this way based on the quadrants, and you
Is that
start.
clear to you?
So you start counterclockwise unless they say, for example, in C where it's like secant
Negative.
negative pi 6, and then you have to go clockwise because that's where it would be negative.
Negative. Right.
Okay.
So I hope that is absolutely clear, right?
1000%, sir.
Very good. So we'll end the class here, but I'd like you to summarize today's learnings.
Yes,
Can you
sir.
summarize what did you learn today?
Okay, so we learned the primary trig ratios, and I think we did that last video too, but this was a really good recap. So our primary trig ratios are sine theta, cos theta, and tan theta. And then we learned our secondary trig ratios, which are cot, secant, and cosec,
Cosecant. Cosecant.
cosecant. And then we learned the cast rule. And so based on the quadrants, you can figure out if they give you like sine of like 100 or sine
Yes.
of 2
100.
pi
Yeah.
over 2. You can figure out which quadrant it needs to be and if your sign will be negative or positive based on the value.
Correct.
And then we also learned special triangles, and the special triangles is what helps you find your value for the
Exact values.
answer, for the exact values. And then we also learned that your ratios, if you have like for example like cosecant or cot or there was another one, secant, I believe.
Secant.
You just take the reciprocal of your actual answer and just make
Yes.
sure that you make the charge related to the quadrant.
Correct. That's perfect. So here we are going to end the class. So try some questions from your book and watch my videos. And then if you have any difficulty, we can always
Sure.
address them. Perfect. All the
Thank
best.
you, sir.
Thank you. Bye.
Have a great day.
You too. Thank you.